What's up, Majors? Brendan here, and welcome back to 7 Days of Injective for day 4. And today we will be learning about precompiles and creating a multi-VM token. This is a token that works on both EVM and Cosmos, taking advantage of multi-VM architecture. So first, we'll make sure that we reuse the starter repo that we had originally, and then we will learn about EVM precompiles, what they are, and the Solidity interface for Injective's bank module. Then we will create a token that implements the multi-VM token standard, right? Which is basically an ERC20 on EVM and a denom on Cosmos at the same time. Then we will do a transfer and we'll also do balance checks. And that's it. So the first thing is we're going to do the starter repo. And today you simply need to cd into the right directory because we already have it checked out from before. All right, so cd day 4. And so you should already be set at this point. So over here, let's go to cd smart contract and run npm install. All right. And the final thing to do is that we have a .n file that we set up previously in day 2 that gives us the configuration that we need for deployment and all of that. So let's just copy that file over here. All right. So from day 2, we have a .env file. We're just copying it into the current directory. So now we have a .n file here. All right. So then the next thing to do is we need to use the faucet again. And that is because deploying a smart contract is a relatively expensive transaction due to the large amount of gas fees incurred compared to regular smart contract interactions, whatever gas fees they occur. However, deploying an MTS token, a multi-VM token standard token, that is even more expensive because it requires not only the deployment of the smart contract, but it also takes a fee where you have to pay 1 INJ in order to do the initial mint. So previously, we used the Injective testnet faucet provided by Injective itself, and this was completely free of the need to authenticate, and thus it needs a lot of protection against DDoS attacks, denial of service, right? Which unfortunately means that the amount it dispenses is low, right? It only gives out 1 INJ, and that's obviously not enough if you need to pay for a transaction gas fee plus the MTS mint fee as well. Fortunately, we have another faucet that is provided by Google, and that is what we'll be using. So let's open up the faucet, right? And we will connect our account, our MetaMask account. Just make sure that we have the right address. So copy the address and then paste that here. All right, so it was the same address. Now what we want to do is to copy this address over here. That's the INJ prefix as opposed to the 0x prefix. And we scroll down and go to Google Faucet. All right, and over here we want to paste the wallet address. Now I have, as you might be able to tell from here, I have already used it because this dispenses 10 INJ, and I'm going to get an error saying that I have already requested, right? So try again after, the specified time, right? So it's going to reject me. But if you're using this faucet for the first time, you should simply get a transfer of 10 INJ into your account. The next thing to do is we're going to talk about EVM precompiles. So let's understand what they are on Injective. So these are not standard smart contracts. They are actually native code that is embedded directly into the Injective nodes themselves. So we expose this native implementation to the EVM through a specific address and an ABI. So when we interact with these addresses within our EVM smart contract, we're not actually running EVM bytecode. Instead, we're triggering the native Injective logic. So think of it as being similar to an FFI, a foreign function interface, where you can say, for example, use Python code to talk to C code. Now, this is similar to that, right? So we're using smart contracts and Solidity to speak to the core blockchain modules within Injective, which happen to be written in Go. And they're also implemented within the Cosmos SDK. Neither of those are understood by the EVM, but because of this interface, this analogous to a foreign function interface provided by the EVM precompile, that communication is made possible. Now, this brings us to MTS, or Multi-VM Token Standard. Injective supports multiple environments, EVM, Cosmosm, and standard Cosmos modules. And we refer to each of these execution environments as a virtual machine, hence the name multi-VM. Usually, these assets in different VMs are fragmented. They require bridges, wrapping, or some other conversion or equivalence translation mechanism. Now, Injective takes a fundamentally different approach to the ones I've just mentioned. With MTS, a fungible token is the same underlying asset across all of the VMs. It is simultaneously an ERC20 token on EVM as well as a denom on Cosmos. And this means that we can use both MetaMask, which is an EVM wallet, and Kepler, a Cosmos wallet, to manage the exact same asset without any conversion steps. So just to emphasize, there's no wrapping, no bridging, none of that involved. It is the same underlying asset that you can interact with using two different protocols, right? EVM protocol, Cosmos protocol. How do we actually create an MTS token? Then the magic happens via the bank module precompile. This lives at a specific address ending in 64, so 0x followed by a lot of zeros and then 64. And its interface looks very similar to an ERC20. And you can see it on the screen right now, right? With transfer and balance functions. But it also includes functions for the balance and mint functions and balance of and transfer functions. But we also have mint, burn, total supply, metadata, and set metadata, right? So these functions are specific to how the bank module within Injective works. And the EVM precompile exposes interface to enable you to interact with it. So to see that in action, right, we can actually take a look within here, look in the smart contracts folder, take a look at the bank.sol file, and this is the actual interface that we will be using. All right. The next thing that we want to do is to implement MTS using bank ERC20, right? Now, there's a canonical implementation of MTS called bank ERC20, and this is actually a base contract that is intended to be extended, which handles the connection to the bank precompile with some basic wrappers around it. At the same time, it also extends OpenZeppelin's ERC20 implementation, and this is all you need to do in order to initialize the precompile, right? So you have the address of the bank precompile, so this is hard-coded, and then you import the interface that we just looked at, and then you say, okay, I am going to wrap it, right? So then now I have a bank object, and I can interact with the bank module in Solidity using this bank object. And let's take a look at bank ERC20 also in the contracts folder. So we can see here, this is the full implementation. Let's actually highlight bits of it like so. So the first up is we have a constructor which takes in a name and symbol and decimals, and then it uses that to initialize ERC20, which is actually the implementation from OpenZeppelin. Now it initializes it with no token name and no token symbol, and that's because instead of that, we're going to be using bank's set metadata function and passing in the actual name and symbols, and of course decimals as well. Then we are going to override several functions from OpenZeppelin, right? So these are standard ERC20 methods that fetch or set data within the bank module. So instead of the standard ERC20 implementation from OpenZeppelin uses a mapping, right? So that mapping stores the key is addresses and the value is the amount of the token being held. The balance of that token being held by each address. So it does that. Instead of doing that, what happens in an MTS token is we send those interactions, we forward them onto the bank module, which is represented by this object, right? And we can say for example, if we want to find the total supply, we query the total supply from the bank module for the particular address. The next thing that we can see over here is that we've got an update function, right? So this is another function that has been overridden. And so what this does is it has some logic for when the from address is the null address, then it performs a mint. And if the to address is a null address, then it performs a burn. And otherwise, neither the from nor the to address are the null addresses. And so then in that case, it does a transfer. And in the full logic isn't shown in each of these cases, but in case of the transfer, you simply interact with the bank module and call the transfer function. So what would happen in a standard ERC20 token is that for mint and burn and transfer, you wouldn't actually do these things. You'd actually basically modify the mapping or the values within the mapping for each of the tokens for the balances. But in this case, you're essentially sending the logic to be transferred, or for minting or for burning, that logic is sent to the bank module, and the bank module will execute the logic for you. Okay, so now we're done with orientation within Bank ERC20. So this is the part that you don't actually need to do anything. The Bank ERC20 smart contract that you see here, they simply need to just copy it from the implementation within the Solidity contracts repo from Injective Labs. So not much for you to do, but just stick it into your hard hat repo. Now this is the part where you actually need to do something to create your own token. So within the contracts folder, also take a look at my MTS token. This has been done for you, but if you want to create your own MTS token, what you'll need to do is create a new contract and extend back Bank ERC20, the contract that we just looked at. And this looks like this, right? So you take in a constructor with some parameters, and then you extend that by calling the constructor of the Bank ERC20 token, and then everything else is taken care of for you. The only thing that I'll highlight as perhaps unusual is that the constructor itself is payable. Now, this is not very common in most smart contracts, although it's technically allowed. And what this means is that when you send a deployment transaction, the deployment transaction itself needs to send some INJ, right? In the case of an MTS token, where you are actually going to mint a token within the constructor, then you need to pay the mint fee, and the mint fee is going to be a hard-coded value of 1 INJ. And that's the reason why you see payable over here. So then what is left for us to do within this is simply to call the mint, right? And that gets us our token. All right, so now it is time for a demo. We're going to compile our MTS token and then deploy it. Firstly, let's take a look at the scripts folder and the deployment script. Now, in day 2, we deployed a smart contract, and the deployment script for that was slightly less complex. And the reason for that was A, because the constructor needs some arguments to be passed inside of it. And the second thing is that the constructor is payable. So the deployment transaction itself, apart from gas fees, also needs to send a value, an amount of INJ together with the transaction. So for that purpose, there is a deploy function that takes in these parameters, name, constructor arguments, and deployment transaction options. And the deployment transaction options are specified here, right? So we're going to pass in a value of 1 times 10 to the power of 18. So that's exactly 1 INJ, as well as a standard value for gas pricing as limit. Now, the constructor arguments, right, we're actually going to specify them in a separate file. And that's over here, right? So this is the name of the token, this is the symbol of the token, and then we also want the initial supply to be 1 million. So those are the 3 constructor parameters that we're sending in with the deployment transaction. the reason why this is in a separate file is because when we get to verification, it just becomes easier, right? Because that's what the verification step expects. All right, let's do this, right? So MTS hardhat run script/deploy.js to run this file, and we specify the network value as INJ testnet. So this is a slightly more complex smart contract, but it's still pretty fast to deploy. And now we can see that we have the smart contract deployed at this address on BlockScout, right? This URL on BlockScout, as well as this address is the equivalent of that on INJScan. And so this is like an EVM native Explorer, and this is an Injective native Explorer, which is more Cosmos focused. So because this is an MTS token, I thought I'd show you both of them. But before we do that, we're going to verify the MTS tokens. So let's copy that smart contract address. All right. So you notice here that I specified constructor args and then specified this JS file, right? That's the reason why I put the constructor arguments in a separate file earlier on. Okay, so successfully submitted source code for contract, and the contract has been verified. So let's take a look at this now. Yep, so the contract has got a tick for verified, and we can see here, this is the contract source code, and my MTS token extends bank ERC20. And we can also see the constructor arguments that it had a name, a symbol, and an initial supply, which is what we expected. And we can also see its ABI over here, right? And this ABI basically should match standard ERC20 token. And also it'll have some additional methods that were specified from the bank ERC20 file that it extended. All right, so you can explore that as well if you like. Now, the next thing that we'll do is to take a look at the other address over here, right, which is this one, right? So this block, this is BlockScout, and it's Injective, it's only for Injective EVM. Now, this Explorer, INJScan, is aware of both EVM as well as Cosmos. Okay. So now if we paste this URL over here, we can see that we also have an ERC20 token that is specified, and it also has a total supply of 1 million. So that matches what we had in BlockScout over here. All right. Now, let's actually make this appear within MetaMask. So you'll notice that in MetaMask, I have INJ, but now that I have minted this and I have the supply for it, right? Why isn't it appearing, right? So that's a question that we want to independently verify. So a couple of ways we can do this, right? We can use the balance of function. So let's actually go to account 1 and get address, copy the address, and paste that over here, and then press read, and see over here, we have the entire supply of 1 million tokens that is allocated to this account. But it's still not showing up over here. Why is that, right? And that's because we haven't told MetaMask that this token even exists. So I'm going to copy the contract address, the smart contract address of this MTS token, and I'm going to click on this triple dot icon over here and then select import tokens and then paste the contract address inside of here. And because this smart contract is ERC20 compliant, it actually has pre-filled values for me. So the token symbol is BGZ MTZ, and you'll notice that, that matches this over here. And it's also got 18 decimal places, which is what we said let it do in the constructor. All right. So would you like to import this token? And it says yes. This does look indeed correct. So I'm going to press import. It says you successfully imported BGZ MTZ. So that's my MTS token, and I can see my balance of it here. we just covered the theory and demos for day 4. Congratulations. Now, if you haven't gone through the steps yourself yet, please be sure to do so right now. It'll only take a couple of minutes to complete. Now, once again, you have some options to do so. One is that you can rewatch this video from the beginning, and the other option for you is to follow the text instructions in the link tutorial down in the description below. Now, in the next video, we will have a short quiz with a couple of multiple choice questions. Now, you should watch that to assess your own understanding of this topic. Thank you for watching, and see you in the next video. But before you go, note that this is a preview edition of the video that is part of the 7 Days of Injective course, and we're creating a full version of this course with all the bells and whistles. And if you watch this far, I'm sure that you'll be keen on that too. So do sign up by using the form or scanning the QR code or clicking the link in the description of this video. For now, on to the next video.